I received this question about relationship between different quantum numbers, and thought I'd just do a short little video to go through all the different variations here. And first off, let me just deal with the relationship between the N principal quantum number and the L quantum number. So one way to think about this is that for each N number, there's a whole set of L and then M sub L numbers as well. Okay, so that's one thing to mind. And I'll just run through the N equals 4, which is a fairly involved sequence, and I'll try to be as short as possible. Because when you say N equals 4, you're really talking about, let me just mark up on the periodic table just for a minute. That's 1s, 2s, 3s, 4s. So when you talk about N equals 4, then you're really talking about this little clump here, and then over here in the P block, 2p, 3p, 4p. So you're really just talking about this specific this specific sublevel, the 4p sublevel. And then for the D block, you have 3D, 4D. So right, then you actually start getting into the D sublevel, of course. And then when you're at N equals, we're again N equals 4. When you're talking about this particular energy level, that also includes some of the F block, because remember, every time you go up a principal quantum number, you add a new sublevel. And so how many sublevels do I have now? I have 1, 2, 3 sublevels for N equals 4, and I also have this one. I have 4. Basically, here, one way to think about it, if N equals 4, that means you're going to have 4 sublevels. And so the fourth sublevel is now this, 4F, 5F. So I'm also dealing with this sublevel when I'm up at the N equals 4 level. What are these different sublevels? Well, okay, so the 4 sublevels, S, P, D, and F. Okay, so I'm going to have 4 different sublevels that I have to express here. Let's go back to the quantum numbers. Okay, so great. So in terms of sublevels, I've already mentioned I have S and P and D and F here, since again I'm specifically talking about N equals 4. And for sublevels, there were, and I mentioned this, just really memorize the relationship. The L quantum number designates what sublevel you're talking about. And the L quantum numbers begin at 0, and then you just count up until basically you run out of sublevels. Again, N equals 4, I got 4 sublevels. My L values for N equals 4 run through 0 up through L equals 3. All right. And then there's this guy. What's the relationship between the M sub L quantum number and everything we see on the page here? Well, for the M sub L, if you're at a S sublevel, M sub L is just equal to 0, okay? And then I can illustrate the trend better when actually dealing with the other blocks here. Because remember, the M sub L quantum number, really what it's designating, it's telling us the number of orbitals in a sublevel. And the equation that's often given for, or not an equation, but the pattern that you see for the M sub L level is something like, it goes like minus L through 0 up to plus L. So what does that mean? Basically, the negative and positive of the L number are sort of like bookends for these M sub L, and just increase it in whole numbers. Let me just sort of quickly run through. For each sublevel, I have a new set of M sub L numbers, starting with minus L. So in this case, it would be minus 1, and I'm just going up in whole numbers, okay? For the D sublevel, I start at -2 and I go up whole numbers or integers. And then for the F sublevel, L equals 3, I apply this sort of same pattern. I start at -3 and I go up in just integers. And, each time you go up to a higher sublevel, you just get a bunch more M sub L numbers. Okay, and I'll relate this back in just a second to the periodic table. Great, so what does all of this mean? Well, if you remember, and let me just do sort of the P block first, and then I'll move down to the F block. We'll do these two on the periodic table. Like for example, for the P sublevel, I said -1, 0, +1. Well, what that relates to are actually the individual orbitals that you see for that sublevel. We learned that there are 1, 2, 3 P atomic orbitals, and the quantum numbers of -1, 0, and +1 designate each of those individual orbitals. Okay? I'll do a specific example in a second. And then for the F block, I have 14 elements in this F block. Okay, and actually that 14 kind of falls out in the quantum numbers. So let's just go through the quantum numbers real quick. Again, I said it was -3, -2, -1, 0, +1, +2, +3. Well, 1, 2, 3, 4, 5, 6, 7. That just corresponds to the 7 orbitals that we used, that we saw on an orbital diagram. Okay. Now, individually, a little abstract. Let's just do ND real quick. Now, I'm not going to do the full orbital diagram. That's pretty involved. For ND, what I can do is, if I march back, descending atomic number, right, what I'm looking for here is xenon. That's the xenon would represent the core noble gas structure, or the core electrons. And so I'm going to do sort of a variation between the, let me do the abbreviated electronic configuration first. Right, I can just put xenon in brackets to represent 54 electrons. And then after that, and let me just remark this, 3s, 4s, 5s, 6s. And since I'm going up 55, 56, 57, actually 3D, 4D, this is the 5D. I'm actually going to move through the 5D. I'm going to put one electron in the 5D sublevel before going down here to the 4F. Okay, so let's just see that. And I would say 6S2, I said 5D1, right? There's one electron, if you will. I'm just, again, when you fill up these, when you lay out the electronic configuration or orbital diagram, you just go up in ascending atomic number and then write down the sub-levels you go through. And in this case, I'm just pausing at one block on the 5D sublevel. That means there's one electron in the 5D sublevel here. And then finally, 1, 2, 3, there's 3 electrons that get up to this guy in the 4F sublevel. Now, if I lay this out in orbital diagram fashion, and again, let me just emphasize this group here. So the 6s, it had one orbital. The 5D, any D, has 2, 3, 4, 5 orbitals. And then the 4F here, well, we're going to have 7 orbitals. And why am I saying all that? Well, because, my M sub L level tells me that 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Here in the D block, 1, 2, 3, 4, 5. And that's what I have. 1, 2, 3, 4, 5. And then I just said I had 7 here. So 1, 2, 3, 4, 5, 6, 7. And then if I want to place these electrons to there, there's only 1 in the 5D sublevel, and then there's 3. And remember, Hund's rule says that if you have a series of orbitals that are degenerate, meaning they're on the same energy level, then you're going to fill the sublevels until you run out of electrons, okay? Or until you double up electrons. Here I'm running out of electrons because there's only 3 electrons to put into the 4F sublevel. And now let's bring this full circle, and now let's designate the 4 quantum numbers that account for that electron's position or energy in the orbital diagram, or the electronic structure for this element. So the in red here, it's N, L, M sub L, M sub S. Okay, so the N quantum number, that's just the number that you see here, that's 4. And then I said that for the F sublevel, we have an L value of 3, so that's 3. And then the M sub L, right? And let me, new color. Right, if I want to do these M sub L numbers, and I'm just going to map it on top of the ones I see here, right? If I want to designate the individual orbitals using the M sub L numbers, and I start at negative L, and then go up in integers, -1, 0, +1, +2, +3. So the M sub L quantum number for that particular orbital on the 4F sublevel is -1, again, based on this pattern. And then finally, remember the M sub S, that's the spin quantum number. What it tells us that if the arrow is pointing up, then that is a +1/2 value. So these 4 quantum numbers are unique to this single electron and the 60 electrons for this element, and these 4 quantum numbers are unique to that electron. That's what quantum numbers are all about. It's a sort of a unique reference to an individual electron. Hope this helped.